So this is the PoolTogether, basically the incentivization mechanisms that are built into the V5 hyperstructure of PoolTogether. I'm just going to run through a demo of all the different bots that generation software has created so far for the V5. And unfortunately, at the moment, we're switching from Sepolia from Gurley testnet to Sepolia testnet. So I'm unable to actually run any of the transactions live on the spot, but I have created some videos giving a high-level overview of the different bots. So we'll just we can just run through those essentially. So we'll start with the DrawAuctionBot. Now, the DrawAuctionBot, its purpose is to get a random number from a random number generator, or RNG. Right now, we use the Chainlink verifiable random function, the VRS service for that. So the fee is actually paid in Link, Chainlink Link. And then obviously there's gas costs as well. So the way this works is we need to get a random number from somewhere. And typically that is Ethereum mainnet right now. And then we relay or bridge this random number each draw every day to the different prize pools on the different L2s. So that'll be Optimism, Arbitrum, Sarah, ZK Sync, down the road, what have you. And we use OpenZeppelin Defender to run these auto tasks, these bots. So every 5 minutes or 10 minutes or 15 minutes, the OpenZeppelin Defender spins up the task and checks the state of the blockchain to see if there's anything that needs to be done. And if it's profitable to do that. If it is, it will submit the transaction on your behalf automatically in the background. And you just make money doing that. So pretty cool. So it just asks you for your OpenZeppelin Defender credentials. And this is what OpenZeppelin Defender looks like over here. Pretty basic, pretty straightforward. You have a relayer, which is just an EOA account. Very simple. You create it for the network that you want to run the transaction on. And then you can create those auto tasks. So for instance, our Ethereum mainnet DrawAuctionBot here runs on the Ethereum relayer, and it runs every 15 minutes. And we can run that auto task manually, but it does it automatically every 15 minutes. And we can see the logs here of all the previous runs that we've done. Back to here. So this is the, I should actually start with the code. So if you're looking for actually running this in your terminal on your computer, you can go to the Generation Software GitHub repo. There's a PT-V5 Auto Tasks monorepo package, which has all of the different bots within it. And you can go through the READMEs to actually set these up on your own computer and test it out as we go along. And so basically all we've done is downloaded this package from GitHub and then run yarn start. And so you see yarn start here. And then it's asking us for the config for the DrawAuctionBot. So there's one other caveat with the DrawAuctionBot is the existing version of the code only looks for one L2, which is Optimism, because so far we've only launched on Optimism. So we're in the middle of rewriting it to support multiple relays, different bridges, or to different chains. So that should be ready this week because we're going to be launching Arbitrum really soon. And it will get the RNG on Ethereum mainnet, and then it will do the bridging to Optimism and Arbitrum and any other relayers that you've set up on different chains. So yeah, what we're looking at here is a little outdated because it's only going to ask us for where's the prize pool and RNG relay auction? But in the future version, it'll ask you how many different relayers do you want to set up. And do you want to set one for all the different chains that you support? So we can see that here. Which network is it on? Optimism. And we need the relayer from OpenZeppelin Defender for Optimism. And then this last one here, or these last two, where it jumps, is who is going to receive the rewards. So instead of the bot, the relayer actually taking the rewards from the prize pool after successfully submitting the RNG start request and the relays, you can have it be sent to a different EOA or a smart contract. Just put in the reward recipient address here, and profit will accumulate for that address that you put in. I can actually show you in this case, we have the Ethereum and Optimism relayers. You can see the Ethereum is 0xA2, Optimism is 0xCE. However, I have my own account that I've put in as the reward recipient, and I have been accumulating those rewards for the draw auction and for prize claims. That all gets accumulated on each prize pool, on each L2. So for the Optimism prize pool, which is the contract that we're currently looking at, I've already accumulated, I think that's 71 to my address for submitting all of those bot transactions. It also asks you how much profit you want to make per transaction. Each bot will ask you that, like, do you want to wait until you're going to make $1 or $2 or $5 for how much you're hoping to make off each transaction. Once you've submitted all of the config for a bot, it will start to run. It will look up the state of the different, just everything it needs to know in order to find out if there's any work to be done and if it's going to be profitable to do that work or not. So you can see here, it'll give us a summary of how much it's going to cost us to submit the RNG in USD. Sorry, you can hear my kid crying in the background. She's having a bit of a day. So you can see that the RNG is going to cost us about $7.50. Oh, sorry, that's the market rate of Link. It's going to cost us $8.35. The RNG auction state is open. Again, this is a recording. This is not live. So this is a previous auction. We were expected to make 34 pool from submitting the transaction. So we take the expected reward is $20 and we minus the RNG fee that we're going to have to pay here to find out if it's profitable. Then we also have to minus off the gas cost that we're going to be paying to see if it's profitable. The RNG relay auction is not open at this time because the basic RNG is, so again, this is the starting the RNG process to get the random number. And after that's done, then you relay or bridge it over to the different L2s from Ethereum to Optimism, from Ethereum to Arbitrum, etc. Yeah, as we go, it just tells you how much Link the relayer currently has, if it can afford to pay the RNG fee. And then it figures out how much gas it's going to cost. So $6.48. It's saying like you're going to make $20 essentially, but then you're also going to have to pay $6.48 in gas and $8.35 in Link costs. So your net profit is $5.36. In this case, I set my minimum profit threshold to $1. Again, you can set 10 or 5 or however much you hope to make per transaction. And because $5 is way more than $1, it considers it profitable. So it does submit the transaction. So we can see that at the bottom here. There's a transaction hash. can see that with the YouTube UI blocking it. There we go. So it just waits for the transaction to be confirmed on the blockchain on the Ethereum mainnet. And once it's confirmed, I mean, in this case, this was the start RNG, so it's gotten the random number. And any of the rewards that you get will happen after the random number has been bridged or relayed to the various L2s and accumulated in the prize pool. So it just gives you a little note to say, this is how you're going to get your rewards. We can actually look up one of the previous transfers of the to get the RNG. So transfer fee, transfer the link fee, and start the RNG request. So that's this was a day ago, and you can see our relayer 0xA2, our defender relayer, submitted that about $10.50 in Chainlink RNG costs and $11 in gas, because gas has been a little bit expensive lately. So it was probably thinking it was going to make 20 something bucks off this transaction, and it submitted it. This is what the relays look like. Similar concept. You don't see an RNG fee because we don't have to pay the RNG fee for this. This is just to relay it to the different L2s. So you're only paying gas costs in this case. So it probably thought it was going to make about $10 or something. So it submitted the transaction, and that reward accumulated over here in prize pool. Along with these high-level overview videos that I've created, there is also a tutorial series on Mirror. So I'll post all these links after the demo, and the tutorial walks through the code. So if you're more interested in how the auctions work and how the code works, you can go through the tutorial. They're quite in depth. And then, of course, if it's all a mystery still, or you have questions, I'm always around. You can just ping me, or you can ping any of the developers in the developers channel to find out more about that. That's the code. That's the transactions. That's the RNG. That's the draw auction, essentially. There's also the prize claimer bot. So prize claiming, similar concept. Somebody is being incentivized to claim prizes on behalf of the winners. All of the bots kind of follow the same pattern and are very kind of cohesive that way, in that they all run on OpenZeppelin Defender, the ones that we've created. You can obviously create your own bots that run on different chronological kind of auto task job providers. But ours use OpenZeppelin Defender, so you fill in your config again. The Flashbots thing is if you want to try and prevent others from seeing your transactions and front running your transactions. So you can, like if somebody's already submitted a transaction and beat you out, it will submit it with Flashbots, which is nice because then you don't have to pay for failed transaction gas fees. And also it keeps it private from the mempool, so other people won't see your transaction and try to copy it essentially and put it before yours and steal your rewards. So that can be really helpful on chains that support it. Again, you can put in your fee recipient address, so who's going to actually accumulate the rewards. Profit you look to make. And then after that is all filled out, again, it will go through and try and figure out, okay, which prizes for the previous draw have yet to be claimed, and are they worth claiming? So in this case, there was a whole bunch of transactions, or a whole bunch of prizes that needed to be claimed. And they were worth claiming. So each one was about 12 cents, 13 cents. You can see that number going up. If we do 7 claims, it's 88 cents we're going to make. If we do 8 claims, it's $1. 9 claims, it's $1.13. So that's the rewards that we're going to make for claiming those. And you can see, because it's optimism, the gas cost of batch claiming that it's really cheap. So if we're going to make $1.25, then we're only going to pay 4 cents in gas, and we're going to make $1.21 profit. So it's good. It's like, this is great. This is very profitable. Let's keep going. Let's see how many of these we can split in one transaction to make those rewards. Now, once it figures out how many there is, in this case, there was 23, it creates that one transaction, that batch transaction, gives you the transaction hash, which you can then go and look up on the Bot Explorer. So here's some recent prize claims that, in fact, the interesting thing about this is our bot sometimes wins these. So this is us down here, 0xCE. But there's plenty of other people right now in the community running bots or running these prize claim transactions. So we are not the only ones that are profiting off of this. There's actually quite a bit of activity from others who are earning these rewards for claiming prizes, which is fantastic to see. And yeah, so a claim prize transaction looks like this. This person claimed 3 prizes. 0x4D, they claimed 3 prizes on other people's behalf. Oh, it looks like they're claiming their own prizes. Whoever 0x4D is realized that they won 3 prizes. And so they wanted to claim them. So they got their prizes, but they also get the rewards for claiming the prizes on their behalf. And that's just baked right into the protocol, the whole reward incentivization layer. That's the prize claim bot. There's the code for this up on GitHub. So you can just run this. It's all open source. And there's a tutorial that's quite in depth on why there's a prize claiming bot, how the prize claims work, how the prize expiry works, how that kind of stuff works, the subgraphs that we use, the way we calculate the prizes, and then deciding if there are profitable claims to submit transactions for. Moving along, we have the last bot, the third bot, which is the Liquidations Bot. And the liquidations are it's a bit complex. There's basically the yield from a prize vault that accumulates over time. So say there's $1 million in the USDC, like $1 million USDC in the vault. The yield for that will generate on Aave automatically. That then needs to be liquidated for Pool because the prizes are given out in Pool, not in USDC. So these liquidations we run by anybody in the community, once again, and they're just converting yield from the vault, from Aave or whatever yield source, into Pool that then can be given out as prizes. Similar concept here. We just get your OpenZeppelin config, OpenZeppelin Defender config. Flashbot, same thing. Reduce failures and keep the transactions private so other people can copy your transactions and front run them. And then who's going to make the profit for the rewards? How much money you want to make per transaction, per swap, essentially. And then it just goes through all of the different liquidation pairs for all of the different vaults and figures out, are there liquidations worth making? Can I, essentially, as a relayer, can I provide Pool and get the USDC or what have you, DAI, et cetera, W? Can I get that token in exchange and provide the prize pool with more Pool token in exchange for the yield token? Once it finds what it thinks is a profitable transaction, it runs through to see what is the most profitable amount it can provide in order to get the most money back. So our algorithm right now just does like, it looks up 100 points between 0 and 100% of the max amount that it can provide to find which one is the most profitable. It then compares that to the amount of gas that it will have to pay in order to run that transaction. And if it deems it appropriate and profitable, it will submit the transaction on your behalf. Continues through all the different liquidation pairs and vaults. If we roll back a bit, you can see there was another transaction that was submitted right there. And then at the end of the liquidation bot run, at the end of each run, it gives you a summary of what happened, essentially. So we didn't actually make $629 here. This is on testnet. So the numbers on testnet don't really make a lot of sense most of the time, but you can see that we submitted 2 transactions on testnet that it deemed profitable. Profit on these is usually around 10 cents to $1 per swap. And once again, we can look up any of these transactions that have happened and see the results on the Explorer. We are still 0x CE in this case. So here's one that we created, but there's other people that are running these swaps, running bots to do this. I believe a few people in the community have even created manual tools where you can just go to a website and put in the liquidation you'd like to make and then run it right from the website. So if you want to make money that way, you don't have to actually run a bot. You can just look up one of those tools. And if we look at one of these, some people have been helping out the protocol while it's V5 is kind of low liquidity while we're waiting for people to move funds over from V4 to V5 and have more depositors. So I believe they're taking a bit of a loss on some of these swaps just in order to help the protocol out. So they're providing $140 worth of pool and only receiving 110 essentially dollars worth of USDC back in exchange. So those are fantastic liquidations for the protocol, not so much for the person that ran this transaction, but it's very giving of them to help the protocol along in these early days. But yeah, you can just look at any of these swaps and see who's making what money, and then it gets sent to what recipient that was provided in the consent. Again, GitHub code for this bot. Also, we'll paste that into Discord. There is a complete tutorial on why this exists, what it does, and how the code works on Mirror, or the video on YouTube. And that's about it, actually. I think that kind of was taking us through all of the different bots, and how the rewards accumulate. There's one other bot that I would mention. So if we go to the mono repo and look at the packages, you can see the ARB liquidator is the one we just looked at. There was the DrawAuctionBot that we did originally, like the first one. The prize claimer that we looked at second. Yield vault mint rate, just ignore that unless you're doing testnet work. That's not a mainnet production thing. And then withdraw claim rewards. This one, I don't believe it's in a working state at the moment. It needs to be fixed, but it will just every now and then, every week or so, look to see if you have any rewards worth withdrawing and withdraw them to your account if need be. So pretty handy as well. Yeah, I think that's about it. So any questions? I completely ignored the chat. I forgot all about the chat. Looks like there's not much in there, so easy. Any questions?
Seems like there aren't. But yeah, that was really great, Chuck. That was very thorough. And I appreciate you being here and waking up so early 2 days in a row. um, so
Yes.
yeah, I did record this, so this will be up on YouTube for those that couldn't make it. But yeah, if no one has any other questions, and if nobody has anything else to add, we can just end it here.
Where would you like me to paste the links in for all these different?
Oh, you can you can actually DM them to me, and then I'll be sure to include them in the description on YouTube.
Okay, and then I guess I'll just put them in maybe the developers channel, because
Yeah.
I know that the chat for this is going to disappear, so it's not very helpful to put it in there. So yeah, I'll put it all in the developers channel.
Okay, cool. Yeah, that'd be great. Awesome. All right. Thank you, Chuck. Thanks, everybody.
Thanks, Darby. Cheers.